Hey, it's Coach Reeves. Today we're going to graph rational equations. Okay? We have a few things that we're going to have to find along the way when we do this. Okay? But the first thing I'm going to ask you to do is we're going to find the domain before we reduce. Everything else we're going to find is we're going to find it after we reduce. Okay? But the domain is the only thing that we're going to find before we reduce. Okay? In this case, that minus sign holds that together, that plus sign holds that together, so we're not going to reduce anything as far as that goes. All right, so in a domain, what I'm going to ask you to do is we're going to set the denominator equal to 0. We're going to move the 5 to the other side. We're going to get x equals negative 5. And then I'm going to ask you to tell me no. It cannot equal negative 5. It's kind of like those excluded values to where the denominator cannot equal 0. But what we're going to say is for the domain, I can have everything to negative infinity. I can have everything to positive infinity. I just cannot include the negative 5. That's the only thing. So those are my restrictions. That's my domain. We're going to ask you to write it in interval notation. So we're going to say soft bracket to negative infinity. We're going to go to negative 5. And we're going to put a soft bracket there because we're not allowed to touch it or make contact with it. We're not going to include it. We're going to have another soft bracket, and we're going to go from negative 5 to positive infinity. Okay? This is how we're going to ask you to find your domain. Got it? As far as holes go, when you determine if you have a hole, we'll talk more about it on the next example. But in this case, if you cannot reduce, if you cannot simplify, you will not have a hole. So what we're going to say is when they ask you for a hole and you cannot reduce, we're just going to say in this case, none. There will not be a hole for this problem. All right? Then we're going to talk to you about a vertical asymptote. We've talked about this in the past, but a vertical asymptote is an actual line, and our graph will never make contact with our vertical asymptote. Okay? So how do you find your vertical asymptote? Very similar to how we found our domain. We're going to find it by putting the denominator equal to 0, but this time we're not going to put a slash. Okay? We're not going to put a slash through here. We're going to say x equals negative 5. That is an equation of a line. That is the vertical asymptote. This is what we're going to write in our blank. X equals negative 5. It's a line, so we have to write it as a line. There's your equation of the line. So we're going to sneak over here and we're going to go 1, 2, 3, 4, 5. There's negative 5, so we're going to draw a line. And this will be my vertical asymptote. Okay? And going through the next one, we're going to ask you to find a horizontal asymptote. And this is a little tricky. Okay? To find the horizontal asymptote, we're going to use an anagram. Okay? We're going to use BOBO, which means bigger on bottom 0. Y equals 0. So it says if the bigger exponent is on bottom, y will be equal to 0. That will be your asymptote. So what does that look like? Okay? If I give you a problem that says y equals x plus 2, and we're going to put this over x squared. Where's the biggest exponent? Well, the biggest exponent is on bottom. So if the bigger exponent is on bottom, this y equals 0 will be my horizontal asymptote. If the bigger exponent is on top, there will be no asymptote. Bottom, bigger on top, no asymptote. So what would that look like? Okay, so if we say y equals, say, 3x squared over, x minus 1. The bigger exponent is on top, so in the blank we would say none. There's not going to be a horizontal asymptote because the bigger exponent is on top. Okay? Eats DC. Exponents are the same. And if the exponents are the same, then we're going to divide coefficients. What this looks like is, what if I had a problem that said y equals 2x plus 3 over x minus 4. In this situation, this is x to the first, this is x to the first. The exponents are the same. So when the exponents are the same, we're going to divide the coefficients. And that would be 2 divided by 1, and you would say that the horizontal asymptote in this case would be 2. Y equals 2. Okay? All right, so let's go back to our problem, see what our situation is. So what we have in this problem for our horizontal asymptote is we have x to the first, x to the first. The coefficients are both 1 over 1. So in this case, we would say that y equals 1. Exponents are the same. We're going to divide the coefficients. 1 divided by 1 is 1. Okay? So my horizontal asymptote is going to be at 1. There's our horizontal asymptote. To find our y-intercept, well, we should know this, but to find our y-intercept, we're going to substitute 0 for the x value. So wherever we see an x, we're going to substitute 0. So back in our problem, we're going to ask you to substitute a 0. 0 minus 3 is a negative 3. We're going to substitute a 0. 0 plus 5 is a positive 5. So when I substituted a 0 for the x, the result was negative 3 over 5. There's my y-intercept. X is 0, y is a negative 3 over 5, somewhere about there. Okay? The next thing is to find the x-intercept. How to find the x-intercept? We're going to ask you to set the numerator equal to 0. Okay? So we're going to go back to our problem. In the numerator was x minus 3. So we're going to say 0 equals x minus 3. Add 3, add 3. 3 equals x. So my x value is 3. And remember, I substitute a 0 for the y. So there's my x-intercept at 3, 0. 1, 2, 3. There's my x-intercept. So we have almost finished. We have answered all these blanks, all the questions we've asked. The only thing I need you to do is to graph it. So what we're going to ask you to do is to maybe have 2 to 3 points, connect the dots, and have a smooth curve. We're not going to grade you on how awesome your graph is, but you need to have a couple of points, connect some dots, and let us know what it's supposed to look like. Okay? To do this, I'm going to ask you to go to your calculator. And we're going to put this in your calculator. I've already done it. I'll do it again for you. Let's go. We'll go home. We're going to go new. We're going to go graph. And I'm going to put in our equation of x minus 3, x minus 3, and we're going to divide by x plus 5. And look what happened. Is that what we wanted to happen? So when that happens, you need to compare what you had on your problem. This is not what we want. So we're going to say Control Escape. And we're going to try it over again. We're going to say we need to get to our graphs. Okay, up. go tab. There we go. Okay, let's try this with parentheses now. So we're going to say parentheses, and we're going to say x minus 3, put it in parentheses, divided by, parentheses, x plus 5. Now, look what we have on our paper. That's exactly what we wanted it to say. Okay? We also know that there was a vertical asymptote at negative 5. 1, 2, 3, 4, 5. You can visualize that there would be maybe a vertical asymptote right there. Okay? But the whole point of putting it in our calculator is so we can go to the table. Okay? So we're going to say Control T for table. And we're going to look, we want to get close to negative 5. We're going to cursor up a little bit. We're going to try some powder points that we can use. I'm going to use negative 1, and negative 4, negative 7. Negative 1, and negative 4, negative 7. 1, 2, 3, 4, 5, 6, 7. Okay? Now that's 4 points. If you just stopped at 3, I would have been happy. We're going to try to connect our dots. Get close to the y-axis, but try not to touch it. There's our graph. Doesn't have to be perfect, just have an idea. But we also need the other part of our graph. We need to be on the other side of the vertical asymptote. This is at negative 5, so we need some points at negative 6 and further to the left. So we go back to our calculator, and we're going to look. And I have a point at negative 6, 9, and negative 7, 5. So we're at negative 6, 9, negative 6, 9. Oops, let's change colors. All right, and we said negative 7, 5. 1, 2, 3, 4, 5. All right, we could find another one, but it's all right to speed this up. My graph is going to come here to here and curve through here. So just kind of give me an estimate of what the graph is going to look like, find me some points, and draw your curves. Okay? Let's go to another example. On this problem, we're going to have to factor first. We need to factor the numerator. When we factor this into 2 parentheses, we know that our signs are going to be different. And we're going to break this down. The x squared will be x times x. And we're going to break that negative 12 down. And we've done these problems before, so I'm going to speed this up. We're going to get 6 and 2, but we want it to be a positive 4. So we're going to put the 6 with the plus sign and the 2 with the minus sign. And then we have to factor the denominator. They have a greatest common factor. They have a greatest common factor of 2x. And this is going to leave me with x minus 2. All right, so we have factored. But before we do anything else, we said before we reduce, before we do anything, we need to find our domain. How do we find our domain? I asked you to take each factor and set it equal to 0. 2x equals 0. X minus 2 equals 0. So you divide by 2, you're going to get x equals 0, and then you're going to say no. You're going to add 2, and you're going to get x equals 2, and then you're going to say no. Okay? The domain is going to go from negative infinity, cannot be 0, cannot be 2, and it's going to go to positive infinity. It's everything except 0 and a positive 2. So how do we write that in interval notation? I want to go from negative infinity to 0, soft bracket because I cannot touch it, okay? We're going to go from 0 to positive 2, soft bracket because we can't include it. and from 2 to positive infinity. There's our domain, okay? That's how you find your domain. Now, your domain and your vertical asymptote sometimes kind of look very similar, but in this case, be careful, okay? Because now, after we find our domain, we're going to reduce. So let's get this out of the way. And now we're going to reduce, okay? The x minus 2's can cancel. And what are we left with? Y equals x plus 6 over 2x. So the next thing we have to ask yourself, is there going to be a hole? Will there be a hole for this problem? Well, did anything cancel? Yes, the x minus 2's cancel. So if you have a factor, or sometimes factors more than one, you will have a hole. You take what has canceled and you set it equal to 0. So the x minus 2's cancel, and we set it equal to 0. We add 2, and we get x equals 2. That is half of the location of the hole. So we're going to put a parentheses, and we're going to say x is 2. And now we have to find the y value. How do you find the y value? You substitute your x value into the remaining equation. So we're going to ask you to substitute a 2 here. What is 2 plus 6? It is 8. We're going to ask you to substitute a 2 here. 2 times 2 is 4. If you reduce this, you're going to find out that y equals 2. So in this case, we will have a hole that is located at 2, 2. That's how you do it. If something cancels, set it equal to 0, take the x value and substitute it into the remaining equation. Okay? All right, so now we found the hole. Let's erase some of this stuff. We need to find out if there's going to be a vertical asymptote. Well, you take to find a vertical asymptote. Let me go back up here. We're going to go back to our problem. Y equals x plus 6 over 2x. Do you remember what we said about vertical asymptotes? Let me see if it's there. No. That's how to find the hole. Just checking real quick. I thought I had a note for you. All right, to find the vertical asymptote, we ask you to take the denominator and set it equal to 0. So what we're going to do is we're going to say that 2x equals 0, divide by 2, x equals 0. There's our line. There's our equation of the line. My vertical asymptote will be at x equals 0. So we're going to draw a line at x equals 0. See the easiest way to do this? There it is. There's my vertical asymptote. Okay? Horizontal asymptote. Look what you have. Exponents are the same. Look, x to the first, x to the first. So there has a coefficient of 1. So in this case, when the exponents are the same, we're going to divide coefficients. Okay? And so 1 over 2. So we're going to say that y equals 1 over 2. Got it? Exponents are the same. Divide the coefficients, so we're going to draw a line to where y is 1/2. Well, that's not very good. Let's try that again. In the middle. Okay. There's my horizontal asymptote. That's as straight as I can go. Okay? All right, so we need to find our y-intercept. How do we find our y-intercept? We said that we were going to substitute a 0 for the x, okay? So we're going to find a 0, or put a 0 for the x. 0 plus 6 is 6. 0. 0 times 2 is 0. Uh-oh. We can't have a 0 in the denominator. So in this case, when this happens, as far as y-intercepts go, we were going to say none. Now, why is that? Well, my y-intercept, we're saying none. Look where the vertical asymptote is. The vertical asymptote, which we know we're not allowed to touch, our graph will never touch the vertical asymptote. It is also the y-axis. So if my vertical asymptote is the y-axis, and we know that we cannot touch the vertical asymptote, there's not going to be a y-intercept. That's why it's none as far as the y-intercept. Now, we're going to find our x-intercept. To find our x-intercept, we ask you to take the numerator and set it equal to 0. Take the numerator and set it equal to 0. Minus 6 minus 6, negative 6 equals x. So what did we get? We got x is negative 6 when we put a 0 for the y value. So we're going to come over here and we're going to put a dot at negative 6. 1, 2, 3, 4, 5, 6. There is my y-intercept. I mean my x-intercept, excuse me. So we have found all our components, okay? But look, we have to put a hole. We have a hole at 2, 2. At 2, 2, we have an open circle. We will have a hole, okay? Now we're going to go to our table. We're going to put this in the calculator, and we're going to find some points so we can graph or finish our graph, okay? So we're going to say new, no, graph. Let me erase this, okay? All right, so we're going to put in, remember how we're going to do this with parentheses. We're going to say parentheses, x plus 6 divided by, and we're going to say 2x. And we're going to say enter. And that's not what I thought it was going to look like. Do you understand? So we have to delete that. We're going to say, we want it to look like this. Remember, look at your calculator and see if it looks like you want it to look like. Okay? Let's do this. Let's go tab. Let's go up. Let's go delete. Okay, so we're going to say parentheses, x plus 6, close your parentheses, divided by parentheses 2x. Sometimes it's okay to make a mistake. You learn the hard way. Enter. This is what we wanted to see. Okay? Control T. Control T. Our table. Now, we want to go to, we're going to use 2, 2. We know that's where the hole is. Can't use 2, 2. All right, we're going to see maybe what else can we pick up? 6, 1. I'd say maybe 3 and 1.5 and 6, 1. 3 and 1.5 and 6, 1. So we're going to go 3 and 1.5 and 6, 1, 2, 3, 4, 5, 6, 1. That's enough. We know that we're going to approach the y-intercept, but never touch it. There's a hole. There's our hole. We don't go through the hole. It's just like a void. All right, let's try the other side. We're going to go into the negative numbers, see if we can find something. I've got negative 2, negative 1. 6, there's the y-intercept. So we're going to try negative 2, negative 1. -2, -1. Oh, let's go to change colors. And let's go ahead and draw it. We're okay. Speed this up. There's our graph. Okay. All right. So what's the tricky part? Probably of all the tricky part is taking it step by step. Don't try to do the whole thing just one big swoop. All right. Go small steps. Make sure you have notes and follow your notes. Okay. Find the domain before you reduce. If something does reduce, if something does cancel, you will have a hole. Look at your notes of how to find the hole. How do you find the hole? Any factors that cancel, it can be more than one, any factors that cancel when reducing are set equal to 0. So we took the part that was canceling, we set it equal to 0. This will give you the x value of the location of the hole. You substitute it in and find the y value. If nothing cancels, then there is not a hole. Okay? So there's two problems. The only way you're going to get to do this is if you practice. And it's okay to make a mistake. It's okay to get stuck. Just talk to us, ask us, we'll help you. All right? Give it a try and see what you can do. Good luck.